All right, so this is just a review for electron configurations because I had a lot of questions today during the quiz, so I want to go over some basics. First of all, on the periodic table, these blocks up here at the top, okay, all of these with the Roman numerals in them, those are just column headers. So this is group 1, group 2, group 3, 4, 5, 6, 7, 8, 9, so forth and so on. Okay, those are not elements. So your first element is hydrogen. All right, so let's erase this. All right, now this is period 1, period 2, period 3, period 4, period 5, period 6, period 7. Technically, the lanthanides and actinides down here, or period 6 and 7. If you'll notice, there's a gap here from 57 to 72, so that's where the lanthanides go, and then there's 89 to 104, that's where these elements go. All right. First of all, helium is over here, but for the sake of electron configurations, I'm going to put helium there. So this over here is the S block. Everything in groups 3 through 12 is the D block. All right. Everything over here in 13 through 18, this is the P block. The lanthanides and actinides down here are both part of the F block. Okay, so if we were going to do hydrogen, hydrogen's right there. That's period 1 in the S block. And it's the first one, it has 1 electron, so the hydrogen is 1s1. If we wanted to do helium, all right, that's still period 1, so we put a 1. It's in the S block, and it's the second one, so it has 2 electrons, so that's 1s2. Okay, if we wanted to do lithium, all right, we've got to start, we always start with hydrogen. So that's our 1s2. Then we come down to the second period, so that's energy level 2. And it's the first one, so that's 2s1. All right, if we wanted to do beryllium, that would be 1s2, 2s1, 2s2. So forth and so on. We keep building. Okay. Another thing I wanted to talk about, like let's say we had, I don't know, silver. Okay. If you needed to find the atomic number and the atomic mass and the mass number, and you need to find the protons, neutrons, and electrons. Now remember, protons are positive, neutrons are neutral, and electrons are negative. So you're going to get your handy dandy periodic table. You're going to find silver. Silver's right here. So you can, yeah. All right. It's element number 47. All right. Now, it's 47. That's the atomic number. The atomic number is always a whole number. And by definition, the atomic number is the number of protons. Right? So immediately, if I've got 47 here, I'm going to put 47 over here for protons. Okay? Now, in this example, they don't give me a mass number. So I'm going to look at the average atomic mass. That's the atomic mass. This is always an average of the isotope. So that's 107.87. Now I can round that. 1.07.87 would round to 108. Hello?
No.
Okay.
How your mash brush is big?
Yep.
You just ate it. And then you go too big.
Yes. All right.
What's that?
I'm recording.
Recording?
Yeah, making a video for my students.
I didn't put it on. What's your write your name? You know how to write your name. Mr. Furlow? Of course his name is Mr. Furlow. Let me see that. That's your name.
Yeah. All right. So now the mass number, remember this, the atomic mass is an average of all the isotopes, right? But the mass number is a specific isotope. And the mass number is the protons plus the neutrons. Now, if I have protons plus neutrons here, and I subtract the protons, that leaves me with neutrons. So if I say 108 minus 47, that's going to leave me with 61 neutrons. These two numbers should equal the mass number. Okay. Now we look at the electrons, and in a neutral atom, protons equal electrons because the protons are positive and the electrons are negative. So if I have 10 positives plus 10 negatives, that equals a charge of 0, right? If I have 47 positives plus 47 negatives, that equals a charge of 0, right? So if I have 47 protons, I have 47 electrons. That's it. All I had to do was calculate the neutrons. Now, there are sometimes you have to calculate the electrons. For example, if you had Ag2+, right? So this is an atom, this is an ion. Now, don't let that scare you. All an ion is an atom with a charge, okay? So my atomic number is still 47 because I still have 47 protons. I haven't changed my neutrons, so my average atomic mass is still 107.87, and my mass number is still 108, okay? 108 minus 47 is still 61, right? So I need to figure out my electrons. Now, if I have 47, like we already said, if I have 47 protons plus 47 neutrons, or 47 electrons, that equals 0. But this charge isn't 0, this charge is 2+. All right? Now, if, let's say, I gained electrons, all right? So I still got 47 protons, and let's say, we're gonna add plus negative 49. All right, well that's gonna give me -2, not +2, so that can't be correct. If I have 47 plus -45, because I lost 2 electrons, all right, that's gonna give me a +2, which is the charge, okay? So I have 45 electrons. Now the key takeaway here is that a positive ion lost electrons, and a negative ion gained electrons. Okay? Period. That's it. Positive ions lost electrons. Negative ions gain electrons. That's it. Okay? So if I had Cl minus, did it gain or lose electrons? That's right. It gained an electron. If I had Mg2+, did it gain or lose? That's right, it lost electrons. How many did it lose? Right, it lost 2 electrons. Chlorine up here only gained 1 electron because it's 1-. Okay? All right, now let's look at the actual configurations. That bit about ions is going to be important coming up, so you need to understand that. All right, let's do, well, we could do a whopper. What if we did, I don't know, let's do krypton. All right, so we're going to do krypton. Now, we want to get to krypton we're always going to start with hydrogen. Okay? So we got to start with hydrogen, and we want to get to krypton. So we're going to start here with the 1s, and I'm going to need my off-bow filling diagram here. Okay? Now, we're not going to use all of those because we're only going to krypton, but we're going to need this. Okay? As soon as we get to period 4. All right? So we're going to start with hydrogen. So that's period 1, and it's the S block. So 1, 2, so that's 1s2. Then we go to period 2. Okay? We got period 2 right here. So I'm going to put a 2. This is the S block. There's 1, 2, so that's 2s2. Then we're still in the second energy level, but this is the P block. So that's 2p, 1, 2, 3, 4, 5, 6. So it's 2p6. Then we got 3. All right. So that's going to be 3s, 1, 2. Then we move over. We're still in the third energy level. This is the P block. 1, 2, 3, 4, 5, 6. So that would be 3p6. Okay. Next, we're going to go to the fourth energy level. So we got to consult our off-bow diagram here. So it's 1s fills, then the 2s, then the 2p, then the 3s, then the 3p, 4s, 3d, then the 4p. Okay? So after the 3p, we're going to have 4s. So that's right here, krypton and calcium. So we're in the fourth energy level, and we have 2, so 4s2. Now, the D block is always 1 behind the period number. So this is period 4, but this is going to be 3D. Okay? And we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 3D10. Okay? Boom. Now we're over here in the P block. So that's going to be 4P. And we're going to go 1, 2, 3, 4, 5, 6. So it's 4p6. And that's krypton. That is the electron configuration for krypton. Now, if you need to do that with arrows, all right, the S block has one sublevel. So for all the S blocks, there's only one sublevel. P blocks have 3 sublevels. 1, 2, 3. D blocks have 1, 2, 3, 4, 5. P blocks have 3. Now, within this 1s, we can have up to 2 electrons. First one, second one. Now, if we look at the periodic table, if we want to double check how it works, it has 36 electrons in a neutral atom. So I have 36, I just used 2, that leaves 34. I go to the 2s, 1, 2. So I use 2 more, that's 32. I get to the 2p6. Now, Pauli's exclusion principle says that these have to have opposite spins, one up, one down. Hund's rule says that I'm going to put one here, one here, one here, before putting a second one here, and then a second one here, and a second one here. All right? And so that's 6, so that leaves 26 electrons. Now we're at the 3s. 1, 2, so that leaves 24. We get to the 3p6. We got to follow Hund's rule again. All right? All right, so that we take away 6, and that leaves 18. The 4s2, you go up 1, and then down 1. So that leaves 16. Now we get to the 3d10. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That leaves 6. And 4p6. 1, 2, 3, 4, 5, 6. All right, so we've used all of our electrons, and that is the electron configuration of krypton. Now, a couple other notes. If you are tasked with finding the valence electrons are the outermost electrons. Okay, so they are always going to be in the highest energy S and P orbitals. Now, I know this 3D is in between the 4s and the 4p, but those are not valence electrons. The 4s and the 4p. Okay? Now, so that would be your valence electrons. If you were tasked with making the noble gas core, then looking at the periodic table, the noble gas before krypton would be argon. So we would write argon, we'd put the symbol in brackets. Now this argon, that ends with 3p6. So this is argon. All right, so then all we need to do after that is 4s2, 3d10, 4p6. Okay, so just remember that for your S and P, those are your valence electrons. The number before the S, so like any number before S or any number before P, that is the energy level. But it's also the period on the periodic table. Okay? So like if this was 3s, then we're talking about the third period of the periodic table. If it was 3p, that would be the third period of the periodic table. All right, if it was 7s, that's the seventh period of the periodic table. If it was 7p, that would be the seventh energy level. If it's a D block, and so the coefficient in front of that, you're going to add 1, and that equals the period on the periodic table. Okay, so like if it was 3D, that's period 4. All right, if it's 4D, that's period what? Right, it's 5. If it was 5D, that's period 6. If it's 6D, that would be period 7. Now the F blocks, the number in front of them plus 2 equals the period. So you're only going to have 5F or 6F. No. It'd be 4F. See, I've done confused myself now. All right, so they're going to be in periods 6 and 7. So you'd have 4F and 5F. 4F is the 6th period, and 5F would be the 7th period because you add 2. Okay? So, in conclusion, you've got 1s, 2s, 3s, 4s, 5s, 6s, 7s. Then you have 3d, 4d, 5d, 6d. You have 3p, 4p, 5p, 6p, 7p. Okay? Down here in the F, you have 4F, and you have 5F. Okay? So I hope this helps. And so what we need to do now is some practice. Okay? So here's what I want you to do. Let me see the periodic table. So calcium, and let's do titanium, and let's do sulfur, and let's do aluminum. All right, so do those as practice and let me know what you get.